Hi there. My name is Nate DeSimone. I'm joined by my colleague Isaac. And
Hello, everyone. Hello, everyone. This is Isaac Oram.
hi. So we're here to talk to you today about the Xeon Scalable processors and how we are building MinPlatform OSF for Xeon. So, just a quick overview of the agenda. We'll talk about how MinPlatform can form the basis for OSF, the initial OSF solution that we will have for the Xeon Scalable processors, and the activities required to port that to your own OCP boards, and a call to action.
So this is the picture that we shared at the previous Global Summit. And this is really our vision for how our reference platforms make it to a diverse open ecosystem. And so that is basically a mix of ingredients that are open source and closed source, are used to produce Intel reference platforms that then scale out to a wide variety of closed and open products. So what is new for the new MinPlatform generation is we take a portion of that Intel reference platform that's historically been proprietary and not been publicly available, and we make an open reference platform out of that. We use binaries, the FSP as the primary binary to keep the proprietary silicon support, but that MinPlatform port will go into the open source EDK2 and can be used to develop Slim bootloader, Core Boot, or any other bootloader. So that's the vision for our open enabling is based on our current reference platforms and a subset of the source and binary that's necessary for a reference platform.
So, what is MinPlatform? So, in a nutshell, MinPlatform is intended to be a vendor-agnostic, reduced feature set UEFI firmware based on Tiana Core EDK2. Uh, Really, it kind of boils down to its middleware for EDK2 to make it easier to build UEFI firmware. The goal is to bring more consistency and more modularity to EDK2 and to break up some of the components that have traditionally not been open source into, first of all, more modular components, and second of all, more open components than there were before. So Tiana Core is one of the many options that you can choose to build firmware compliant with the OCP OSF checklist. We're working on making MinPlatform one of the premier solutions for OSF, at least on Xeon Scalable. And really, it's about trying to make it easier to build firmware that matches the traditional ecosystem, but in a way that brings openness to it without necessarily having to restart from the very bottom, right? So the key benefits is that we're leveraging the industry standards for UEFI, ACPI, all of the hardware standards that we support with that to enable this open system firmware, and that gives you much wider compatibility with all of the existing both operating systems and option ROMs that are out in the market. So if you pick some random SCSI card and plug it into a system running MinPlatform firmware, there's a very good chance it will work, even though it hasn't really been tested necessarily. So this is really intended to make it easier for system vendors to build OSF firmware that is compatible with all the existing current solutions. So for Xeon Scalable, our ingredients to build MinPlatform really come down to two categories. First of all is the redistributable but closed binary components, the most prominent of those being the Intel Firmware Support Package. We will also have a FV late silicon that we'll talk about in a little bit. And then any option ROMs or device firmware binaries that you might need to complete the system firmware image. You know, DMC, ME, chipset, that kind of thing. The second part is the open source code. And this is really the board specific part of the solution, as well as the open source base MinPlatform implementation that Intel will provide. So we'll provide the base MinPlatform with most of the code required to make a MinPlatform based board port. And we'll also provide a sample board port that uses an Intel RVP that you can then adapt to create your board port for your own board. And of course, it's fully compatible with UEFI and EDK2. So if there's any value-added features that you wanted to take from an IBV, then it's really easy to integrate them into this design, but entirely optional as well.
So one of the pieces we want to introduce and talk to today is from the minimum platform architecture spec, which is available on tnocore.org. And this is the FV late silicon. And it's not a fancy name. It's not a great name. It is for the UEFI code that's the later phases of the PI architecture. So the later phases would be Dixie, SMM, BDS, things like that. So this is proprietary silicon code for those later UEFI boot phases. And so these are the silicon features not initialized by the Intel FSP. The key things they provide are register access capabilities. It's fairly common for a server code to want to touch pieces of the silicon, and there's a fairly complicated namespace for doing that. So we provide the drivers that give those register access capabilities. There's some processor initialization code in Dixie along the MP sphere. There's power and performance configuration activities, NVDIMM support, IIO and PCH initialization, and all of the SMM dispatchers for CPU and chipset. And so these pieces are bundled up into a UEFI firmware volume that can be added to either a MinPlatform port that's in the open source, or it can be added into other bootloaders using the UEFI payload package. We have longer term desire to make this more flexible and have more like an FSP API mode interface to it, but that's not what we're going to see first generation. So first generation, we would rely on UEFI native bootloaders or bootloaders that can use the UEFI payload as a basis for implementing UEFI. So the other piece that we want to introduce today is where to look in the EDK2 platforms tree and the FSP repo for these things. So these are just links to the EDK2 platform repo and the shared MinPlatform package. These are common PIMs and drivers for implementing your board port. They define the libraries that you need to implement and basically instantiate the common part of the architecture. The Intel Silicon package is common silicon related code. The Cedar Island Silicon package will contain FSP dispatch mode interfaces. The Cedar Island FSP bin package will contain the API mode interfaces, as well as the binaries for the FSP and the FV late silicon. And then the Cedar Island open board package is where the reference board, the Intel reference board port is. So the key point is if you're doing a simple board port that's based on an Intel reference platform, you would add your open system firmware port here and be able to leverage our reference platform. If you have a fairly different board layout, board design, you might want to copy the whole Cedar Island board package and make your own complete board package. So it's designed to work either way, where you just add the minimal library porting interfaces and content implementations for your board, or you take it as a reference and create your own.
Okay, so to create your own board port for MinPlatform, there's really a very small number of things that you need to adjust. Perhaps the most important is the platform configuration database, PCD. So this serves roughly the same purpose as the FSP UPDs do in API mode. So we use this to store all of the configuration knobs that is either going to be passed to the FSP or passed to FE late silicon, depending upon what part of the flow we're in, as well as configuration options that would be used by the open source components, both just the straight board as well as any open source advanced features that you may want to include. The second thing you need is something we call the universal board abstraction. I'll talk about that in the next slide. And then the final thing is just board libraries. So there are several libraries defined in the MinPlatform specification that you need to implement in order to build a MinPlatform board port. The most important of these is board initlib. It's very similar to mainboard.c in coreboot, actually. There's another, there's a few others as well. Like there's one for very early code, sec board initlib. There's a late one for BDS flows. There's relatively optional though. You can use the generic ones that are provided in MinPlatform, or if you want more customization on either sides of those flows, you can implement your own as well. And the silicon configuration goes largely into the PCD database, as discussed prior. So UBA is a architecture that's primarily designed for enabling the porting of GPIO pinmux configuration easier, as well as features like SMBIOS, where the strings you want in your SMBIOS table are going to be very different depending upon platform A versus platform B. So the way UBA works is basically every board gets its own PIM. And that PIM goes and initializes any of the GPIOs or SMBIOS strings or FSP configuration options, which in the MinPlatform case would be stored in the PCD database that are required for this particular board. Those go into a centralized UBA configuration database that is then used by the MinPlatform standardized platform preem MPI driver to pass configuration to both the FSP as well as the later phases of MinPlatform. Okay, Isaac?
All right, thanks, Nate. Yeah, so the UBA is a key bridge between the way the proprietary solutions work and the open solution will work. Longer term, we'd like to converge it, but this is one of the technologies that allow us to leverage the existing implementations in the existing ecosystem. We'd been hoping to have the Cedar Island open source by this event, but unfortunately 2020 being what it was, nothing quite went according to plan. So we're still focused on that as our next step. We're working on the initial release of the Cedar Island OSF ingredients. So we're looking to get the MinPlatform board port into the open source and get the various platform binaries available in an early proof of concept form. So keep an eye out for that. We've provided the locations and you can watch the various repos involved and pay attention on the EDK2, join the EDK2 mailing list and get that content when it becomes available. And then as we look at 2021, we're looking for the initial release of the Whitley OSF ingredients, and that will be more widely used, we believe. So those are the two key things that we're working on with respect to MinPlatform, is completing our first really spec conformant version that's open, and then working on the second more widely more widely desired target. Next slide, please. So the main place to engage in with us for open system firmware is, of course, the OSF community, and so the link is there. We'd also love to see your OSF MinPlatform ports added to tianocore.org in the EDK2 platforms repo so that we can leverage the work together. We'd also like to complete the MinPlatform specification. It's still a fairly early version of the specification with a lot of room for evolving to meet other needs. And then below are the links for the tianocore development mailing list where all of the changes go and designs are discussed, as well as links to MinPlatform training material if you'd like to dig into the details of porting. They've got Whiskey Lake examples galore. So thank you very much. And I think with that, we move to questions and answers, open discussion.
Let me see if there's been any comments. I don't think I saw any.
I have not seen any comments either.
I did just add a couple of people to the live Zoom. So if you were just added, feel free to unmute yourself and ask the speakers a question.
All right. Well, I guess maybe one thing I could briefly talk about is I really think MinPlatform is going to be really good for the circular economy that we're trying to build with the OCP OSF ecosystem. Specifically, I could imagine the need for a more industry standard based firmware solution being used after a system is recycled and then repurposed for another use. Perhaps the next customer would then install something more custom as their firmware, but it would make sense that after the initial recycling and sale on the open market, that by default it would come with something that's much more standard. Now, the OSF checklist doesn't necessarily require that second resale actually use OSF. So, it could be that just gets a closed source firmware implementation at that point. But I think that MinPlatform enables us to potentially do better than that and actually have, the second reuse of the system be an open source firmware open system firmware as well. And also, MinPlatform, while Intel may be doing the development right now, doesn't necessarily mean that we've tried to make it Intel specific. So if you're working with other SoC vendors, you are more than welcome to use MinPlatform as part of your OSF as well.
So Nate, we did get a question from Ron on as to if we believe we can meet the one shell script goal of OSF, one script for a given board that magically does it all. So I'm assuming this is around building everything, pulling and building everything you need. And I have to say that we haven't looked deeply into this yet, but I do believe for at least the basic open systems firmware, once all of the binaries are available, we should be able to automate any piece of the puzzle for constructing was the word used for constructing a firmware image. In terms of flashing it into a system, I think those kinds of things might take a little more work to evolve. But for today's build, once we get the components out there, we believe it should all be available in the open for constructing a firmware image.
Yeah, and the rest of it is just software, right? I'm sure we can write a shell script that fetches everything and puts it together.
Yeah, I think with the most recent Intel platforms, we have broken most of the proprietary tool links required. And so we can use open GCC tool chains, and we'd like to move to Clang and LLVM at some point. We have the repos are all on GitHub that we're utilizing for the firmware components, binaries, and source. And so once those access pieces are in place, I think it should be very scriptable.
Yeah, and perhaps another little bit of color that I could add is we've, at least on Cooper Lake and Ice Lake, Isaac and I have been engaged with several different customers that are working on building OSF solutions for those two chipsets. So what at least has been my general observation is that there's really kind of two things that people are looking at. It's either core boot or MinPlatform. And my observation has been that those that had chosen to start with MinPlatform are probably about 6 months ahead of those that chose to start with core boot. And I think that's just because it's much closer to what Intel uses internally. So it's been much more quick and to get them, enabled and get to high quality.
So there's a question from Christian on how do we plan to close the gap between starting development and making code public? Will these be aligned at some point in time? For example, once QS samples are available, the open system firmware should also be available. Right now, we don't see a path to aligning with QS samples, so it will be post-product launch before we can release the open board port in most cases. We have some ideas to improve that, to make more of the development in the open over time, but there are some constraints that we have today that we don't see a way around. So I don't think we see as early as QS, but we do see as early as product launch in the future.
But in general, we are trying to be open earlier and more open in general as time goes on. That's absolutely something we're trying to do. It's just a question of how much we can do when, and that kind of thing.
So the next question is there an inexpensive desktop development target for MinPlatform? Yes, there's an up extreme target for client that's there today, and we would recommend that as the baseline. We'd like to see some more activity, as it's hard for us to maintain that alone, but it's there and it's interesting.
So I see another question here. With open source firmware, is there a way to address the problem where a security patch was released but not applied by everyone, but adversaries found a way to create an exploit based on the fix for the vulnerability? So I'd say that firmware update has been a problem across the whole ecosystem, especially in the case of the traditional supply chain where there's let's see, from silicon to ODM to OEM to customers. So there's 3 levels of indirection in the traditional supply chain, which makes it hard to get these updates out. So it's one of the things that we hope that, just being more open source will help address, is that removing some of the copy, adopt, modify levels in between the SoC vendor and the end customer should hopefully help reduce the issues with getting updates out in a more timely manner.
Yep, let's wrap it up, Nate. So short answer, we don't have a solution right now that's greatly improved by that, but we do believe open source software will help and will move us in the right direction. So thank you, everyone, and have a wonderful afternoon and follow-up sessions.